Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the Red Planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guessed that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the Smoking Hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on Smoking Hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right. But experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the Smoking Hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the Smoking Hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now, it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The Smoking Hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red-striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the Smoking Hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the Smoking Hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. but you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity, the rover has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history. Where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now, it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
Mars is a dry, rocky, and barren planet. It's difficult to imagine that once upon a time, the red planet could have had a landscape similar to ours. But scientists believe that this is the case and that millions of years ago, Mars was filled with vast oceans of water. In early 2021, NASA sent their most advanced rover yet to the red planet. Its mission is to search for any signs of microbial life that hint at the planet's past. They named the rover Perseverance, or Percy for short. Even Percy's initial landing on Mars itself was a scientific discovery. The rover landed using auto-navigation along with onboard cameras to track the planet's surface and find the ideal spot to land. This helped scientists work out the best landing options for future missions to Mars. Percy currently roams the red planet, guided by a new and highly advanced auto-navigational system. The majority of his day is spent analyzing rock formations. Percy is decked out with a high-tech laser that fires a tiny pinpoint beam into rocks. The laser creates a plasma from the rock samples. Then Percy's onboard spectrograph analyzes the plasma to identify the chemical composition of the rock. 2 of Percy's most significant findings so far are rocks that have been nicknamed Mazi and Yigo. These words come from the Navajo dialect, in tribute to a NASA engineer from the Native American Navajo tribe. Mazi means Mars, and Yigo means diligent. These two rocks are both salt-like in composition, meaning they are igneous rocks. If you're not familiar with your rock species, igneous means that the rocks were formed from a volcanic eruption. The current shape of Mazi and Ego suggests that they have been molded by a watery environment. This could be proof that Mars was once filled with water. Another interesting rock discovered has been nicknamed the Harbor Seal. This is a dark, smooth rock that scientists believe had been sculpted by powerful northwesterly winds to resemble the playful marine animal. For decades, scientists have theorized about the wind and weather patterns on Mars. This finding seems to support their existing weather modeling of the planet. Percy has sent back over 20,000 images since arriving on Mars in February, including an internet-breaking selfie. Audio files have also been sent from the Mars mission. For the first time ever, we can listen in to the eerily and ambient sounds of extraterrestrial winds on the Martian landscape, all thanks to the rover's onboard microphones. For the first time ever, oxygen has been produced using human technology on another planet. Inside Percy is a gold-plated box around the same size as a car battery. This is the MOXIE unit. MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. Yeah, that's a bit of a mouthful. 95% of Mars' atmosphere consists of carbon dioxide. The MOXIE unit diffuses the carbon dioxide and, through an intricate chemical process, turns it into oxygen. The unit has produced a modest but still historic 5 grams of oxygen. This works out to around 10 minutes of breathable air. It's also a good sign for what could come in the future. Who knows? Maybe one day MOXIE can produce enough oxygen to support a human colony on Mars. For now, scientists are more focused on MOXIE producing enough oxygen to create rocket fuel. In order to propel the standard-sized modern-day spacecraft off of Mars, you would need 7 metric tons of rocket fuel and 25 metric tons of oxygen. This would be far too heavy for a spacecraft to bring from Earth. So if there is ever to be a manned mission to and from Mars, there needs to be some way to create fuel on the planet. For those of you worried about Percy being lonely, he actually has a special companion up there with him. Stowed inside the rover on his descent to Mars was a small but expensive helicopter named Ingenuity, but you can call her Ginny for short. The mini helicopter cost NASA $80 million to develop, but every penny was worth it as Ginny made history by performing the first powered drone flight on another world. Ginny was a massive scientific feat, as engineers originally struggled to design a helicopter dinky enough to be stowed on an interplanetary rover, but powerful enough to take flight on another planet. After the success of Ginny, scientists are now collecting data from the one-of-a-kind helicopter to aid in the design of smart micro-drones here on Earth. The helicopter is used to explore terrain that is unsuitable for the rover. Ginny hovers over the Martian landscape, collecting data and taking aerial photographs to send back to Earth. Ginny is powered by solar panels above the rotor blades. A big concern for scientists was that the panels would get covered in thick coatings of Martian dust and leave the helicopter powerless. Luckily, airflow from the blades actually self-cleans Ginny's solar panels. Inside her mechanisms, Ginny carries a small postage stamp-sized piece of fabric from the Wright brothers' historic 1903 flying airplane. This is a loving tribute to the original pioneers of aviation. The Curiosity rover first landed on Mars back in 2012 and has been roaming the red planet for over 12 years. Curiosity wasn't designed to detect life as Perseverance was, but instead to determine if Mars had any of the necessary elements that could sustain life. This includes things such as liquid water, carbon, energy sources. Curiosity found a site scientists called Yellowknife Bay. This site once contained an ancient lake. The rover discovered minerals left behind from the waters, showing that the lake water was not too acidic or too salty. It would have had a balanced pH. Carbon, nitrogen, and other elements that could potentially support life were all found within the crater of the ancient lake. And most important of all, Curiosity found potential sources of energy for microbial life. So maybe there could be existing life on Mars after all. Curiosity made history by being the first Mars rover to witness and measure a planetary-wide dust storm. Just like on Earth, wind constantly blows on Mars, grinding away at the geology. This creates lots of dust, which eventually gets whipped up into large clouds. The dust clouds absorb sunlight and heat up, making the winds more intense. Without any rain or oceans, every few years the clouds grow so large that they wrap around the entire planet and create a giant dust storm. In 2018, Curiosity witnessed one of these great storms from the Martian surface. It noted that sunlight on the planet decreased by 97%, and many large sand dunes were left behind. Curiosity has spent more than a decade measuring the radiation environment on Mars. This allows scientists to work out if humans could safely visit the red planet without turning radioactive. So far, the news is encouraging, and the Mars radiation levels are comparable to those experienced by astronauts aboard the International Space Station. This means that astronauts could endure a long-term round trip without having to worry about radiation too much. Mars is home to the largest volcano in the solar system, Olympus Mons. This giant volcano is 14 miles high. That's about 2.5 times the size of Mount Everest. The volcano was formed millions of years ago, a time when Mars was filled with countless volcanoes, spewing molten lava across the planet's surface. Olympus Mons is a shield volcano, so rather than violently spewing lava and flames up into the air, lava would flow slowly down the sides of the volcano. This gives it its low, squat appearance and an average slope of only 5%. At only a few million years old, Olympus Mons is still a fairly young volcano. Because of this, scientists believe that it could potentially still be active, so maybe it could erupt at some point in the future. The Curiosity rover doesn't just eye up the local geology, it also takes a note of what's happening in the sky. In March 2021, it captured these shimmering iridescent colors in the sky, named mother-of-pearl clouds. This colorful display occurs when all the cloud particles are nearly identical in size. It usually happens shortly after the clouds have formed. Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants. And plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because, however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments.